Stage is yours.
Thank you. Thank you.
Sharing the screen. Now your turn.
Nice. Okay, let me know when you can see it. All right, should be good. All right, welcome everyone.
But it's not the full screen.
Yeah, it's fine. We're gonna go like this.
Good.
So yeah, thank you Thomas for the introduction. Really happy to present Loki here today. And definitively don't hesitate to ask a question at the end, especially if it's related to Elastic. I'm more than happy to answer those questions, just to clear everything out. So today I'm gonna just give you a quick introduction to Loki, but before we do that, I just want to give you a quick summary of how it started and how it's going. So the project started in 2018 at the not the ObservabilityCon, but the KubeCon in North America, and that's David Kashmith, which is working at Grafana Lab with me, and he's introducing Loki for the first time. So that was like more than 3 years ago now, October 2020. So last October. That's what you can do now with Loki with just logs. So hi again, everyone. My name is Cyril. I'm a software engineer at Grafana Lab, and I mostly work on Loki, sometimes on Cortex, but I really enjoy working on a distributed system. And you can reach out to me via those different URL or tags or nicknames. So the talk's going to be in 4 parts. We're just going to talk briefly about the motivation and the problem space. I want to give you a quick introduction to why we created Loki, what's the reason behind Loki. And then we're going to go through a quick overview and an history, how we get to today. And then we're going to look at how the architecture is, what's the data model, because I think the data model is pretty interesting in Loki. It's what actually makes it very much different than other log aggregation system. And then at the end, we're going to quickly spend some time talking about what's the 2.0, which is the current major release, and what we're looking at in the future. Right, let's start with motivation and problem space. So at Grafana Labs, we kind of like set ourselves to solve 3 problems with Loki, but not really re-implement Elasticsearch. Problem number 1, we wanted to make sure that we can have a tool that is simpler and developer focused. Something that is very simple to use, simple for DevOps, simple for SREs, things that remind them how they use the grep experience, and that's basically one of the big goals of Loki, making sure that it's very easy to use. Second, we wanted to make it super simple to scale. So this is two log aggregation systems that currently or were existing or currently exist, and that scale pretty well, works very well, are pretty fast and very easy to use. Again, the idea is the idea of OKLog is really just simple log, raw logs, no indexing. Just give me the file, and I'll do the search myself with all the Linux tool that I know of. And because this is simple, usually that means this will be very easy to operate and easy to scale. Right. The third problem that we wanted to solve is make sure that we have a log aggregation system that is integrated into your tooling. You probably can relate to this slide here if you're working on a company using a lot of different tools. You can have maybe Oracle, you have AppDynamics, New Relic, whatever. You have like many different observability tools in your stack, and sometimes when you are within an incident, it can be cumbersome or very difficult to navigate through those tools to find the root cause of your problem. So the idea that we want to have with Loki and the Grafana stack as a whole is make it much more simpler, much more easier, and to find the root cause of your problem. But even if you're not using Loki, even if you're not using Prometheus, Grafana support a lot of different data sources. So this flow should be able to be achievable with whatever backend you are using. So the flow is pretty simple. You wake up in the middle of the night, you have a page, you look at the dashboard, probably a boring dashboard like this showing you errors, and then you want to explore those errors. You want to jump to logs so that you can get more context on what's going on, and then jump to a trace maybe if you have a tracing instrumentation, and hopefully you can find a fix and fix your problem. So that's the motivation. That's why we created Loki pretty quickly. Now let's see. Let's quickly dive into what's Loki and the history of it. So this is like the big shout out for Loki, like with a lot of buzzword. But the idea of Loki is being like Prometheus, but for the logs. And I'm gonna insist on that because really we wanted Loki to be working closely with Prometheus, and so there's a lot of similarities, and it's heavily inspired by Prometheus. It really focuses on developer and engineer. It gives you a global view of your application logs, and because it uses the same metadata that you will have with Prometheus, and if you know Prometheus, we're talking about labels, and if you have the same labels, the same service discovery for your logs and for your metrics, then you will be able to pivot from metrics to logs very quickly. At the end of the talk, we're going to just quickly do a demo of that, so that I can show you exactly how that looks like. And again, the Loki, because we want this thing to be super simple to operate and super simple to scale, and it's inexpensive because I'm going to explain later, but it's inexpensive because we don't really index the log itself. We only index the metadata. So we index basically just a set of label, pretty much like Prometheus does. Only the discovery, the label, the tags of your workload will be indexed. And so you can search your logs via those tags. So a bit of history. First commit was in 2018 by Tom, who is the author of Grafana Loki. He has a very nice design doc that is still out there if you want to have a look at what was the idea at the beginning. And then quickly we become very popular. A lot of contributors are now contributing to Loki. And this is like a list of big features that we release over time up to now. So in terms of community, I think we are now over 13,000 stars. I guess we all know that GitHub stars are probably the most prevalent way of knowing if a popular is how popular a project is. Obviously, I'm just kidding here. But yeah, it's still, it means like a lot of people are looking into the project, are interested, and that's something that we really appreciate and we're really happy about. So that's a graph of data source being used of Loki in the wild via Grafana. This is pretty good. We can see that there's a lot of data source, and that's only people who are opting in for for sending data analytics, and we are like more than 25,000 data source out there in the wild running Loki, and that's actually a very good growth since last year. But this is, we're just getting started here. So let's have a look at how Loki works in detail and talk about the data model. Just to put it very simply, Loki is a system that you can send logs to, and you can then query back those logs with either Grafana or Log CLI. So how do you send logs? There's a lot of different ways to send logs. You can use different clients. We have our own client, which is called Prometheus. And we usually prefer people to use Prometheus. The reason is because it's tailored for Loki, so it will use the same service discovery of Prometheus, and that's why we call it Prometheus. And if you are familiar with Prometheus and configuring Prometheus, it's going to be a breeze to configure Prometheus, because this is the exact same configuration, the same service discovery. So all those will be very similar, and so it should be very simple. However, we know that there's a lot of disparate system out there. There's a lot of people running, Fluentd, Docker, Logstash, syslog. There's a lot of possibility, and we support a lot of different clients so that you can send your data to. So a brief overview of what the integration looks like within Grafana. So you can see we have like two panels here. One is showing metrics, the other one is showing logs. Now we can even show logs and traces next to each other. So you're going to see that now it's even better. But just wanted to briefly touch on Loki is really well integrated into Grafana. So if Grafana is something that you use, you should really have a great experience here. So talking about the data model, as I was saying earlier, only the metadata of the log will be indexed. And if you look at this slide here, we're looking at the Nginx application and the IP of the instance. That's pretty much all that's going to be indexed. Obviously, the timestamp also is indexed so that you can query for a given period or a given time range. But then after, we don't actually index anything with regards to the log line itself. So if you think about this means that the index size is going to be very much smaller than the content itself, which is not always true for other systems. So how we do that? So for all those different pair of key value pair, we call that a stream. So it's like a file for let's say a given pod in your cluster if you're using Kubernetes, or for a given application if you're not on Kubernetes. And we're going to compress those logs, and then we're going to store them into an object store like GCS or S3. And then after, we're going to be able to query them back using this small index. So just to put a bit into perspective what I just said about the index, in our cluster, we have like more than 300,000 streams, so 300,000 applications running in our cluster, and actually it's actually more than just one cluster. It's generating around 10 terabytes of data, and that's for a single day, and that gives you an index for a single day of 200 megabytes. And that means that the index itself is just 15,000 times smaller than the data. If you look at other systems that are indexing the whole content, you usually end up with the index bigger than the content itself, because you have to re-index multiple times the same word to map to the different JSON objects. So that's you're going to end up with an index that is actually huge, and big index usually means operation nightmare. Operation nightmare because it's a lot of data to store. It's much more difficult to compress, and so at the end of the day, the idea of Loki is just to make it very, very much simple to operate at scale. In terms of storage, we rely on a giant shoulder of giants, and so most of the time we store those tiny chunks from the streams into object stores like Swift, Azure Blobs, GCS, and we also support file system if you're running just a single replica of Loki. So a lot of people now are probably wondering, like, how is this working, right? Like, how can he query a lot of amount of data and find a word or find the logs that he wants? The way Loki works is actually we scan the data with a lot of parallelism. when you actually want to do a search. So the data set is not using, is using, you know, at first a small index so that it can maybe look at just, instead of looking at 10 terabytes of data, we're going to look at 40 gigabytes of data. And then we parallelize heavily the queries to multiple queries, and that allows us to run at 40 gigabytes per second. So that's like 1 terabyte scan of data in 25 seconds. So obviously it's never going to be as fast as an index, but just to put into perspective that, you know, it's still fast enough for most of your log needs. So there's multiple ways to run Loki. Loki scales actually very well. This is probably a very scary architecture diagram. You don't have to run Loki like this. We run it like this at Grafana Labs for our SaaS product, Grafana Cloud. And this allows you to inject, you know, terabytes per day or even per hour of data from a lot of customers around the world. So there's, you know, a lot of different paths that can scale. The write path can scale differently from the read path. We can have a lot of queries that are small application that can decompress chunks and then search into the chunks what you want, the word that you want. But just to give you, I'm not going to go too much into detail about how all of this works, because usually, you know, if you want to get started with Loki, that's not how you should deploy it. You should deploy the single binary. So there's another version where it's just like Prometheus scales pretty well vertically, especially for a single Kubernetes cluster. It's well enough. This is really just to show you that Loki can scale above a single Kubernetes cluster if you need to. So I was talking about query parallelization just to show you how this works. We have a component called the query front end. When you search for an error in a whole namespace, it could be, you know, a lot of data that you're touching, but you're just using like a single value of the index to reduce down to, let's say, a couple of gigabytes of data, and then we're going to send, you know, those small queries, small chunk of query to different queries, which each of them run at 400 megabytes per second approximately. And that's going to give you, for instance, a 1.6 gigabyte of scan per second. Obviously, you can scale higher if you have more queries. There's a lot of other ways to parallelize in Loki. That's just one of them. If you're more interested into that, there is like a couple of blog posts about how we parallelize query in Cortex. Which is a project that is very similar to Loki, and it's actually scaling Prometheus. And those two blog posts are super interesting to you know, learn about how you can leverage sharding and all those techniques to run very fast queries. So that's the same that we are using in Loki. So I'm just putting the blog post here if you are interested. And that's how, again, that's how we run this in Grafana Cloud. So let's look at Loki 2.0, which is the current major version, and then we're gonna briefly touch on what's going to be the future for Loki. So 2.0 was announced last year, October, at the ObservabilityCon, and it focused really on 3 big features. First one is extracting metrics and manipulating those metrics from the log line itself, and that's something new that you weren't able to do before. And then creating alerts, which goes, you know, well in pair with extracting metrics. So now that you can extract metrics, you can also create alerts, and those alerts will work along with your alert manager, the same alert manager that you're using with Prometheus. If you have one in your cluster, you don't need another one. You can use the same. The alert will be routed to the same alert manager. And then the last part was, you know, real-time interactive dashboard. So being able to add your logs directly in the dashboard, or use those new metric queries to rate errors, or being able to maybe do some black box monitoring. You know, that there's a lot of applications out there that are just logging, that are not instrumented, or you cannot instrument them. one of them is well known as Nginx, for instance. It just output logs, doesn't give you much metrics. There's an exporter for Prometheus, but doesn't really give you error rate or anything that is interesting enough to build alert. So I'm just going to touch briefly on those 3 points. The new, we call it LogQL, which is the language that Loki uses to query the logs, and it's heavily inspired by PromQL, which is the language for Prometheus. And so if you already know how to use Prometheus, how to use PromQL, it should be very, very familiar with Loki, because it's pretty much the same language. There's just a couple of addition more in LogQL, because you can search for log, which metrics you cannot really search for a metric. It's just a simple float value. Logs have actually strings, so you can search within those strings and find those results. And the idea is, if you have an Nginx server, we want you to be able to extract those 400 and rate the 400, or maybe even look at the path, which path is having the biggest latency. So that's just an example of a query that shows you how you can manipulate now the log line. Also, you can rewrite the log line. So if you have a log line that is in JSON, you can parse it, and then you can output it differently. It's using the same language as the Go template, which has been very popular with Elm. If you have ever used Elm, this is the same kind of text template from Golang. That's another example showing you, you can run quantile over time on logs, right? So there's a duration somewhere in my logs. Every time it prints a duration of something happening, like a request. And using Loki and LogQL, the new features, you can extract that value from the logs and graph it directly in Grafana. So that's again that's pretty much the same slide here. So this is a dashboard that has been built by someone at Grafana, just to show you everything you can do with Loki. That's an Nginx dashboard, web analytic dashboard, showing you can even do mapping with a country on a map. You can show the logs of the latest request on the side. There's a lot of things that you can do, and all of this has been built only with Loki. That's a dashboard that I built. I'm going to show you that after. So second point, alerting from logs. So now what you can do is you can write the rules, the same rules that you are used to write in Prometheus, but instead of using PromQL, you're going to be able to use LogQL, and you're going to be able to write those rules and being alerted and receive a page and route them to Alert Manager, and receive a Slack message when something is happening, like too many errors or something has been leaked, like a secret should not be there. And there's a lot of possibility now. Basically, alerting on log is a super powerful tool. Grafana Cloud has also an interesting version of that, where you can use a specific UI and then you can see the evaluation in real time. So that's when you're using Grafana Cloud. And I'm just going to do a very brief demo of all of this. I want to show you the workflow, the workflow of that I talked about at the beginning of, you receive a page and you want to find the logs of related to that page. And then we're just going to show you a dashboard that I built recently. So I'm just going to refresh here, just making sure that everything is back. Okay. So let's imagine, it's really late in the night. I wake up, receive a page, and this is the dashboard, how it looks like. So I can see, like, I have a 3-layer type application where there's like a load balancer at the top, and then the application that communicates with the database below. I can see definitely something is going on with the database. And so the first thing usually you want to do is start exploring. So by the way, this is Prometheus. You want to start exploring, maybe drill down to a specific time range. So maybe I'm going to select this one here, right? This spike of 500. And then because, as I was saying, because the labels in Loki and in Prometheus are exactly the same, when I switch to Loki, so I should make sure I don't do the mistake here. When I switch to Loki here, it's going to automatically actually keep the same labels and show me the logs for this application, the application that was outputting this metrics. Right, so there's a lot of logs, as you can see, probably not enough to see all of them. And I'm not seeing any error here. So I'm going to start to do a search. So in Loki, the search are like grep style. There's different type of grep that you can do. You can do direct search. So this is equality. So the log must match this value here. So let's say I want to find an error, right? I can enter. So I can find some errors that are happening. And if I click on show context here, I can actually see, within the stream of that log file or application where that error is. You can also do, so if you need to do some regexes, you can do regexes. So this is the regex version, right? So you can do, for instance, insensitive case, insensitive search. So if I want to find all the errors, whether they are in capital or not. And you can chain multiple of them, right? Like something related to connection, right? So it's going to drill down and you can, okay, so I can see this is only specific error for connection, right? And you can chain a lot of them like that and find the errors. I just want to maybe zoom a bit so that everyone can see correctly. If I click on a log line itself, I can see all the labels that are attached to it. You can see that we selectively pick labels that describe the workload. So I can find this workload very easily. This is the database in the TNSDemo namespace. That's the pod. You have the cluster name, in which cluster this is currently running, the container name. And then there is like a couple of detected fields by Grafana. This is automatically detected by Grafana. You can quickly do some ad hoc analysis to see, how many percentage of this of errors are too many open connection. Currently, it's 100% because I'm only looking for those ones. If you want to add more matcher at the top, you can click on the plus and it will only focus. So you see, you already added the namespace matcher. So the way it works is, everything within this square, within this bracket, sorry, are the matcher for the labels. So that's selecting a stream. And then after you do the search like I was doing here. So I'm like filtering down, removing things that I don't need. And you can do the opposite if you need to. For instance, I want to only see anything that is not an error. And that's going to only show me when I don't have an error. All right, so that's for searching. There is other stuff that we can do. We can start to do metric queries. So I can rate all of this, and I can show how often my application is receiving traffic, right? And so we can see that there is actually two different streams here. One is debug log, and the other one is not debug log. I can sum all of this. I can sum by container, for instance, container. So by any label that exists, right? And I can show the data by container. I only have one container here, but if I remove the job here, which select a specific container, I can run that query. I'm going to have more container now. I have like 3 different containers. I'm going to switch it back to I want to see errors. So I can see the error happening here, the rate at which it's happening. I'm going to go back to 6 hours to have a bit more info. And I can see that this was happening for a while. And you can drill down and find, and then troubleshoot your problem using those metric queries. I'm going to go back to logs. Right. So I'm going to go back to those log here. Right. So now let's look at another use case. You can, for instance, if you have an error, so we're going to try to find an error. I want to show you that, which is pretty fun. So if I found an error, but I also want to find the log line that has a trace ID, and maybe instead of error, I'm going to say 500, right? And I know that it's in parentheses. So I want to find anything that has a 500 in my namespace. So then, across multiple applications. And I want to also see the trace ID. Like I only want to see those logs with trace ID. Right, so I can see those 500 here, and I can see that there's a trace ID. If I click on this one, for instance, I can click to a link, which is gonna take me directly to the connected tracing backend, if you have one. In my case, I have Tempo, which is the backend for this demo, and I can directly jump to a trace from Loki, and I can look at what this request did over my system, to which services it went through, and when it started to error. We can see that I start to have an issue at this point, and you can see that it's we can drill down into the tracing part of the event. So I'm going to stop that, and I just want to show you now that we can parse those logs. So you can find that maybe irritating that you don't have a lot of logs, and maybe there's others information that you want to extract. And for instance, maybe I want to extract the get, right? The get here. So I'm going to try to do so 500. Right, you see this get here. I'd like to use it as a label, but if I click here, I don't really have this as a label anywhere. And so I just want to show you that now you can extract. So I'm going to try to write a regex, which it's been a while. So you can extract regex. You can extract using multiple different parsers. So we have the regex one. We have JSON. If you have a log line in JSON, we're going to quickly see the JSON after, or even log format. So this is actually log format. If you know this language here, this is log format. So if we do log format, I run this query. And now if I look at the labels, they are much more different. I have the label that I didn't have before. I have a message. And I have the trace ID, right? So I can already start to do some interesting metrics using those new labels that have been extracted at query time. So I could, for instance, count the time and then sum of all of this, sum by label. Label is not a label that has been indexed, but I can still aggregate on an indexed label, right? I have only warning, so maybe I can remove that. Some log line are not in the correct format, so I'm gonna just use a way to ignore them. So you just set the error label to empty, so it filters them out, and I can see all my application logs by label, which is not indexed. We're going to end the demo on that small dashboard here that I built for the Observability last year with Loki, just to show you how you can integrate Loki into dashboards. So we're going to briefly go over all of this. You can see that the first thing you can see, it's a 6-hour time range of a lot of different clusters here. So it's pretty efficient. And we have the average latency per cluster here, which seems to be a pretty good latency, except for that cluster. You have the percentage of error here. All of this is built only with Loki, LogQL. You have again here the latency over time, but this time like the P90, you can even see the P99. So this is a quantile. You have the median, which is the P50. You can see the request per status. And then at the bottom, we have only the requests that are actually slow. So let's drill down a bit into this panel to see how I did this. So this is an Nginx container. It's actually outputting logs in JSON. So maybe I want to show this very quickly, just to show you how the logs are. Right, so this is like Nginx log, but in JSON, as you can see. So the labels, they are pretty empty, right? But there's a ton of possibility I can do with all those data here that I can use and I can aggregate on. So by just adding this extractor JSON here, everything's going to become a label. The JSON is going to be flattened out, and you're going to be able to have all those new labels that you can aggregate on. You can use as a metric. You can rate by, sum by, max over time, quantile. There's a lot of possibility. Everything that you were able to do with Prometheus, you can do it with labels that are extracted at query time. So this thing here is doing exactly that, and is doing a rate of the 400 here. You see only the 400, only the 200. So that's how I build this rate per second of 500, 200, and 400. We can look at the latency one, which is a bit more complex. This one, so again, I'm doing this stream selection plus the JSON to extract the values. And then I said unwrap on a specific label, which is the latency. Unwrap means take this specific label value, and if we look at one here, it's a latency, this one, you see, this value here, take it and use it as a sample value, as a metric value. And this is in seconds. And then once you've done that, calculate the quantile of all of this and the 99 quantile and do it by cluster. And so that's how I get quantile per cluster, all of those queries. So I have multiple queries here, I have the median here and the quantile. I think that's it, yeah, just two of them. And the last one, I'm just want to show you how I did this slow request. So this is just the slow request log there, which is pretty cool. If you're a SRE and you receive a page, you can quickly jump to a dashboard and see all the slow requests that may have impacted, let's say, a SLO alert that you built. So I can edit and see that, you see, I'm doing the same here, but this time I'm looking at request time. If it's superior, so I can do operation like this with extracted label. If it's superior than 50 seconds, then I'll put it in a specific format. So this is showing, you see, a specific format. So I'm only showing basically the path, the status, and the latency. Let's go back to the presentation. We're close to the end. Hopefully I haven't lost everyone. So let's talk about the future. This is pretty cool, but like I was saying at the beginning, Loki is just getting started. Like it's just, you know, basically 2 years of real development, 1 year of beta. We're just getting started. There's a lot of feature that we want to achieve. So custom retention is one that we've been looking at for a while, and I've been working on that for the last quarter, and this is finished. I'm actually slowly deploying that over our cluster to test it, make sure that everything is working properly. But custom retention allows you to say, for a given stream or a given file or a given application, I just want to keep that log for a week, or I want to keep it just for a day. I want to keep it just for a year, maybe for GDPR reason, or maybe it's because it's access log of my application. I want to make sure that I keep those logs longer than the rest. And I know that the throughput of those logs are not super high, and I can afford the cost. But maybe if you have like a development environment that logs a lot with the debug level, but you can say, oh, this one, I'm fine to keep it just a week. You can also do that per tenant. We're going to support log deletion. So currently you cannot really delete data via an API. You can only delete directly in the object store. We also working on creating recording rules. So the recording rules, it's the same as like the alerting rule, except that it will generate metrics, and then those metrics can be sent to any Prometheus or Cortex or Thanos, and you can save those time series data into those time series database. There is a constraint currently in Loki. You can only send data in order. It has causes a lot of problem for people that are running function as a service, like Lambda, which it's very difficult to organize the logs of those workloads. So we're working on removing this constraint. We're going to introduce more parsers. So currently we support only JSON parser. We support the log format and the regex, which probably is good enough. Like the regex is supposed to be the last one that you use if you're not using the two previous one, and that should fit all your use case. But the regex one is a bit slow. So we want to introduce new other way of parsing your logs, like a glob, for instance, or space-based token. We're gonna insert new filters. So IP filtering, you want to filter on a specific range, being able to find, all the errors only for that specific range, so that you can identify, let's say, maybe a node that is, having an issue, or maybe only a network that is having an issue. We want to work on top K estimation. So top K is a query that you can run currently on Loki, but it's limited to a specific amount of time series, and at some point it's not really working very well. So we want to look at doing estimations instead, right? Because Loki has a lot of data. Creating estimation might be a better solution to scale. And we always constantly improving the storage. Like we're always trying to make this project cost efficient. I think that's pretty much the end of the talk. Thank you everyone for listening up to here. Loki is available. It's open source. It's on GitHub, on the Grafana org. If you wanna have a look, and don't hesitate to reach out to me also on Twitter. I'm also on Slack, on the Grafana Labs public Slack, on the Loki channel. Thank you again.